Okay, in this video, we're going to be working on writing equations of lines. This is the last topic in this chapter. All right, so when it asks us to write the equation of the line and get it into slope-intercept form, let me go ahead and, okay. That slope-intercept form, that means they want us to come up with an equation that looks like y equals mx plus b. Oh, and by the way, this document is in the course documents in our Blackboard course. Thought I would do some videos because I know some of you might be working on your math over the break and might like to go ahead and get started on this. All right, so on this one, we know the m and we know the b. And see, what's going to happen is we're trying to come up with an equation that's y equals some number times x plus some number. And the m goes connected to the x, and then the b goes where it is just added to all of that, goes where the b is. So on this one, you basically have what you need. And the answer to the question is y equals -8/9. So you put that where the m is with the x, and then plus, and right here you put your b. Okay. All right. So that one gave us the m and it gave us the b. So we basically just had to put it into that slope-intercept form and we had the answer to the question. And this is what they'd be talking about. So we're kind of doing the reverse of all the graphing of lines that we did early on. We don't know the equation to start with. What we know is information about it, and we're trying to come up with an equation. Okay. All right, so now on this next one, we wind up having the m and having this point 0.06. But let's talk a little more about the b. Let's remember that the m is the slope, and the b over here, that's the y-intercept, okay, which means that's the point where the graph crosses the y-axis. So like, say your line is right there, it would be that point. And so a point that's on the y-axis always has a 0 in that first spot. So 0, some number, something like that, 0 with a number after it. That's going to be a y-intercept. If you notice that, you can save yourself a lot of time. So see how this point is 0.6, and if you were to plot 0.6, it would be right there on the y-axis. That means that b equals 6. So if you notice that, you can come in and put in the b and put in the m, and you have your answer. M is -4/5 and b is 6. So your answer would be -4/5 x plus 6. Okay. All right, now the third one also can be done that way because we have this point 0, 0, and see 0, 0 is the origin. So that is the y-intercept. This is your b, the second, because that's 0. You have to make sure that first coordinate 0. So one more time, we know our m and our b is 0, but then 2x plus 0 would still be 2x. So that's our equation right there, okay? All right, now let me go back and grab another collection of these, okay? So the fourth one really fits with those other two because you basically can get the m and the b right there from the graph, okay? So let me grab these and we'll go over them. So when you're doing one where they give you the graph, okay, one thing that we don't, we weren't explicitly given the m or the b, so we have to think about it. We know we need the slope, but we know how to do this. We did this earlier. If you're trying to find the slope, you might try to find a couple of points. The intercepts are a lot of times good ones to use if it hits right at one of those tick marks. We can find the slope, can't we? So we're going to find the slope. Okay. We're going to find b, and then we'll plug them in. And b is the y-intercept. So we're going to find the slope, we're going to find the y-intercept, and then we'll just plug them in. So if we're trying to do the slope from a graph, what I talked to you about doing is trying to just think about slope being the rise over the run, and counting to find it. So on this graph, I can see that I would have to go from this house to here. If this is what I'm doing, I'm going from that spot to that spot. I'd have to go up some amount, and the amount I'd have to go up appears to be 5. Then I'd have to go to the right this many, and that looks like it would be 1, 2, 3, 4, 5, 6, 7. 7, and both directions are positive. Up 5, positive 5, to the right 7, positive 7, and that's 5 7s. So that's my slope. All right, now to identify the y-intercept from the graph, you can see that it crosses the y-axis right there at 5. So the y-intercept is the 0.05. Okay? So B would be 5. So we're going to go in now. We're going to say, all right, my job is to get the equation. So in place of the M, I'll put 5 7ths. And in place of the B, I'll put 5. Now don't forget the X on that. See, if you left off that X, if you wrote just 5 7ths plus 5, that is wrong because that's just 5 and 5 7ths, which is just a number, and that would be a horizontal line. So don't forget the X after the slope. And then that's the answer to that one. Okay. Now on problem number 5, I'm given 2 points, but I'm not given the slope. So I usually take a look at things and I think, okay, well, I know I'm going to need the slope. So let's get the slope. But on this one, I'm looking at how I've got points to work from. So there I'm basically going to use that y2 minus y1 formula. But remember, all it really does is say to subtract the y's, and watch it when you have one of the y coordinates being negative. Subtract is part of that formula. And then the -4 is the actual y coordinate. All right, so you're going to subtract your y coordinates. And then if you started with 7 when you subtracted 4, if I started there, then when I do my x's, I have to start with the 9. All right, so that makes it 7 minus -4, which is 11, and 9 minus 0, which is 9. All right, so that's my slope. All right, now I've got to think about trying to write the equation. So when I go to try to write the equation, the issue I have is, or the thing I've got to think about is how to get B. And so I like to go back to my points for a minute and think about them. And if I do that, I notice once again, on this particular one, I'm able to find my B. I'm actually given my B. See, 0, -4, that would be down here. That is a y-intercept. So I know that B equals 4. -4, sorry. So if I'm going to write my equation, I would write y equals 11/9 x minus 4. And that would be what they want. Now, these first 5 that we've done on all of them, you basically had the y-intercept given to you. You basically had the B value. All right, number 6 is the one that you need to really understand and put an asterisk by. All right, this one right here gives us the slope in this case, right? We know the M value right there. But this point, -9,5, notice it would be off of the y-axis. It is not the y-intercept, okay? So not B. That 5 is not the B, okay? Because that point is not on the y-axis. All right, so with what I'm going to recommend that you do on these is that you start, and you'll be given the formula. You just need to know to use it. We're going to use a formula that's called the point slope formula. Okay, and here's what it looks like. Y minus some y coordinate equals M times X minus some X coordinate. And they use that Y1 and that X1. Remember, those are just subscripts. Okay. And the point slope formula, you use that when you're given a point or when you have a point in the slope. And you can use it to get the equation of your line. Okay. All right, so what you do is where you see the x1, y1, that's where you plug in the point. And then, of course, the m being -5 is going to go right where the m is. So keep the y coordinate with the y. So the y and the x are what are the y and the x that are going to be in your answer. So you're going to do y minus 5, because the y coordinate at that point was 5, equals -5, because that was the slope they gave you, and then x minus, and the x coordinate they gave you was -9. Okay. All right, now at this point, you have the equation, but what you got to do is you've got to clean that up. So you're going to wind up having to distribute and do a bunch of other stuff. Okay, let me go to a whiteboard to finish this up. So the point was -9.5 and the slope was -5. Go to a new one. Okay, so we're working on number 6. Ooh, I like this better. I may just keep working over here. So this is number 6 from the sheet. So what we did is we used the y minus y1 formula. And you'll be given this. It's called the point slope formula. We plugged in the slope, and then we took and we plugged in the point. And this is some specific point, and you're going to plug it in. Just keep the y coordinate with the y coordinate and the x coordinate with the x. And be careful when you have those negative coordinates. This minus and this minus, that's part of the formula, okay? Now, once you've plugged in, you're just going to do things like this. X minus -9 is x plus 9. What I'm doing from this point to the end is just going to be getting it in slope-intercept form. Okay, so I'm going to distribute, and I wind up with -5x minus 45. And then I just need to add 5, because slope-intercept form is y equals mx plus b. So I need the m to be by itself. So I need to add 5. When I do, I get that y equals -5x minus 40. Okay? And that's the answer on number 6. Okay? All right, so this is something new. Number 6 is important. It kind of tells you what to do when they don't come right out and give you the slope and the y-intercept, but you've got to do a little bit of work. Okay, so let's go back and look at that sheet for a minute. Where's the snip? There it is. Okay. All right, so that one right there wound up being y equals, I've already forgotten, hold on. Y equals -5x minus 40. Y equals -5x minus 40. You see, we didn't get the 40 until after we did all of that work. All right, so the big difference between 6 and everything prior is all the ones prior to this, you basically had the b value. You see, I'm going to do it in green. This actually was on the y-intercept, so that was b. Here we could find the b by just looking at it, and it was up at 5 units, so we knew that was our b. Okay, and then on the previous ones, let's see if I can get it to move over. Let's see if I can bring it. Okay, and then see here they gave you the b. Here this was the b, and here that was the b. Okay, well that's very atypical. I just wanted to have problems that kind of progress through all the different things, and you can keep comparing what you're trying to do with what you already know how to do. Okay, so number 6 is going to be really important, because that's one where you weren't given the b value. You didn't have it to start with. Okay, all right, now let's go ahead and continue on this. So what if we're going to do 7 and 7. Okay, so on 7, on that one, I'm looking at it and I don't have my m, and see how neither of the points have a 0 in that first spot? That means neither point is on the y-axis, right? Okay, so neither point's on the y-axis. All All right, so your plan on this one is going to be I've got to get my slope. Okay, so get your slope. Okay, let me do that in red. All right, so find your slope. And since you're given 2 points, you're going to find your slope by coming in and taking the y's and subtracting them. Doesn't matter the order, but they need to both be y coordinates, and you need to have a minus in between those y coordinates. Some of you may have done -1 minus 8. You'd also be correct. What's important, though, is when you do your change in x's, that you do it in the same order. So see, this would be -9 minus -4. And this would be -4 minus -9. Both of them are going to turn out to be the same thing. The slope here would be a +9 on top. And then that's really -9 plus 4. So that's a -5 on the bottom. Whereas over here, we get a -9 on top and a +5 on the bottom. But whether it's negative on the bottom or the top, okay, we know that our slope is basically a -9/5. Okay. All right, now the issue is that neither point is the y-intercept. So that we've got to do that work, we've got to use that idea of doing y minus y1 equals m times x minus x1, because we don't have the b value. Okay. Now, it doesn't matter which point you use when you go to plug in the point in here. It doesn't matter which point, you'll get the same answer at the end. So what I normally do is I come back and I look for a point that maybe doesn't have any negatives, okay? Or if I have my slope like this, I look for one that maybe is a multiple of 5 in the first spot. Okay, but these are both basically going to be the same. I'm gonna use that one because it doesn't have as many negatives. But this one's going to not turn out so nice. Okay, so I'm going to keep my y coordinate with my y, put in my slope of -9/5, and then keep my x coordinate of that same point with my x. Okay. And then from here to the end, all I'm doing is cleaning up the equation. So minus a negative becomes plus. So this would be -5/9 times x plus 9. Okay, I'm going to distribute. And I can use my calculator to help me with that fraction. That -9/5 times 9 turns out to be a -81/5. So I can just write minus 81/5. Okay. And then I need to add 8 to both sides. And when I do, I wind up with -9/5 x, and the -81/5 and the +40/5 is -41/5. Okay. And this right here turns out to be the equation for that line for number 7 would be y equals -9/5 x minus 41/5. All right, now let me show you. Let me go over to the whiteboard for a minute. That was -9/8 and -4, -1. -9/8 and then -4, -1. No, -4, 1. Okay, that was number 7. All right, so let me show you. Make sure I got that right. -9/8, it is -1, okay. And then -4, -1. All right, now let me show you what would have happened had, after we found the slope, we did all this business to get our slope, and we got it to be a 9 over -5 or -9/5, and we came here to plug into the formula, which will be given to you. You just need to know how to use it. If I had used the -4, 1, I would have put the -1 with the y, put in my slope, and put the -4 with the x. So that would be y plus 1 equals -9/5 x plus 4. Okay, so it looks like it's different, but watch. When I distribute that, I get a -9/5 x minus 36/5. Again, it feels different, but I'm not done yet. Okay. And now I'm going to subtract 1 from both sides so that I get my y by itself, and I get a negative 9/5 x. And this is negative 36/5 minus 5/5, which is negative 41/5. So you see, it doesn't really matter which point you use. The equation is going to have to be the same because those 2 points are on that line. So both of them could be used to write the equation. And so, we got that negative 9/5 x minus 41/5. See, we got that same thing. Okay. All right. So up through 7, 6 and 7 are really important because they are more general than the first 5. And they kind of show you how do you approach a problem when they don't give you the slope and they don't give you the b value. Okay. And so you'll be given this formula right here, and you just need to know how to use it. So if they want an equation, you're going to have to write something like y equals some number times x plus a number. Okay. And so your job is to figure out the m and have the b value there. All right, now I'm going to go back to the original sheet because I want to grab 3 of the next problems. So after number 7, 8, 9, and 10 all go together. All right, now they're different from the others, you'll see. 8, 9, and 10, they kind of all go together. Okay. All right, what's going to happen on these is these are all going to be special. And you might notice that best by seeing that horizontal, undefined slope. And then see here how those x coordinates are the same. That means that situation, you really have 6, negative 10, and 6, negative. You really have a situation where the lines line up vertically. Or the line is a vertical line, is what I should have said. The points line up vertically. So these are all going to be problems where the equation is going to look like y equals something or x equals something. And on these, I want you to reason it out and not depend on a formula, because the formula, either formula, does not work if you have a vertical line. Okay, so let's just be thinking through it. All right, so let me kind of start it off. All right, so what you would do on this one is you would start by getting your slope. So you don't yet maybe know whether it's a special case or not. You start by doing your slope. So you're going to take the change in your y. So you might have set it up negative 3 minus negative 10 or negative 10 minus negative 3, as long as the y's are on top and both the y coordinates were negative, and then the minus was part of the formula. Then I go back to the point that had the negative 10 in it, and I pick up its x, and it just so happens the other one is also 6. So that means I get that 0 on the bottom, and on top, I have negative 10 plus 3, which is negative 7. So look, negative 7 divided by 0, when you do that, that's the one that gives you an error on your calculator. That means slope is undefined. It doesn't mean the equation doesn't exist. It just means the slope is undefined. Okay? So at that point, you need to think about the situation. And I think the best way to think about it after you notice that weird thing happening is to, let's do it over here, is to graph the points like I did earlier. So just think about where they are. 6, negative 10 and 6, negative 3 would line up vertically. And notice already, if you organize those points in a table, see how you have a 6, negative 10, and then a 6, negative 3. What's going on is, wouldn't every point on this line have a 6 in that first column, no matter what? So your x's are 6. So the slope was undefined, but they didn't ask for the slope. They asked for the equation of the line, and the equation of the line would be x equals 6. The slope is not 6. A line with a slope of 6 would do something like that. Okay, the slope is not 6. The equation of the line is 6. And that's what we want here. We want equations. Okay, so really I think drawing a picture is going to be your best bet on these. All right, on this one, I see that horizontal. That means the slope has to be 0. If you remember that, you can use it. Okay. One thing that I think helps is to plot that point, -3, and then you'd be up at 7, right? So this is the line right here. Horizontal is that way. That's the line I'm trying to write the equation for. So I really would like for you just to draw the picture and think about it. And so ask yourself, well, what would be true about every point on this line? Not only does the given point, this given point was -3, 7, but wouldn't all of the points have a y of 7? So the equation of that line would be y equals 7. All of the ordered pairs on that line would have a y coordinate of 7. That's the answer to this one. Now, you do have a way of working this one. Because it was the horizontal type, you could have had the slope is 0 and take that point right there, and you could plug in to the y minus y1 equals the slope times x minus x1. You would have that possibility because the slope did exist. It wasn't like the undefined situation. And then you could come in and plug in the 7 and the -3. And so y minus 7 would equal 0 times x plus 3. But look, that's 0 times something. If you distributed it, that's 0 times x and 0 times 3. This whole side is going to be 0. And so we wind up with y minus 7 being 0. And so y equals 7. So that one, you would have a backup way of doing it using that point slope formula. But you don't have that luxury when you have a vertical line or an undefined slope because you don't have a number that you can plug in. You have to reason it out. So I really would prefer you just reasoning it out anytime you have the horizontal and vertical situations. And the best way to do that is to actually picture it. All right, so on problem number 10, for instance, we got that undefined slope situation, which means we can't plug something in for slope in our equation. So you should just picture it. So here's 2, -8, somewhere down here. All right, you should think undefined slope, I can't walk on it. So it's that situation. So here's my x, here's my y. This is the line that I'm trying to write the equation of. So look at that line. Imagine these points on that line. Can you look at that and see how all the x's are 2? Then the equation would be x equals 2. See, there's no other way to do it. Okay. Now, what is true? Let me go to a whiteboard to say this. What would be true? And I'm going to go ahead and put that information here. This is true. If you have a horizontal line, horizontal situation versus a vertical line. Okay. All right, horizontal lines. Let me write that better. Versus vertical lines. Okay. And I'm just going to do an example to start with. With horizontal lines, that means you've got a line that looks like this, right? Okay. Where a vertical line means you got a line that's up and down. Let me put the y and the x on it. Something like that. So when you look at these, horizontal lines always have the same y. So for instance, maybe that's up at 2. So the y's would always be 2. So the equation of the line would be y equals 2. With the vertical case, okay, let me put that at 2. See, you'd be looking at this and you'd be noticing that all the x's are -2 on that one. That means the equation for this would be x equals -2. Okay? All right, now, this one has a slope. See, the slope would be 0 here. Over here, the slope is undefined. Okay? You know, if you wound up trying to calculate, like the slope of this. You might have the 0.32 or the 0.02 or the -5.2. Those would be points on the line. And if you started to try to do it using a formula, wouldn't it have the change in the y's on top, and then whichever points you picked, maybe I picked these two and these two, then it would be like -5 minus 3. But see how the 0 would be on top? That's why you get a slope of 0. Where over here, the y's could be anything. You might have gone up 5 or remained on the x-axis or been down -1. If you had tried to use the slope formula, maybe using these two, you might have done 5 minus 0. But then that -2 minus -2, that's going to give you a 0 on the bottom. 5 divided by 0. That's the one that gives you the error. This is the one, when the 0 is on top, that winds up equaling 0. Okay? All right, so let me summarize this better. So horizontal lines versus vertical. Okay? Horizontals are always y equals some number. If you looked at it, if you had the ordered pairs, it means the y coordinates are always the same. Vertical lines are x equals some number, and the x coordinate is always the same. And whatever it is, that's what helps you get your equation. Okay. The slope of horizontal lines is always 0. The slope on vertical lines is always undefined. Okay. Let's see. Let me draw them. All right. So if you had a horizontal line, doesn't have to be in the positive side. I'm just giving an example, versus a vertical line. Okay. And so that information kind of all goes together. But don't memorize it. I want you to be able to figure it out and to think about it. And the best way to do it is to represent things visually, plot the point like I did. Oops, it's not on here. Let me go back to the sheet for a second. It's on this one. Okay, so approach it like this. Look at it. Okay, here were the 2 points. Look at it and think about it. And if you do that and you're trying to get the equation, you should be able to go from that picture to this equation. Okay, plot the point -3.7 and think about it being horizontal. And from that picture, you can reason out it's y equals 7. Okay, plot the point 2, -8. Undefined slope. So that means it's up and down like that. Look at that picture and reason it out. And you can see that all the x's are 2. Okay? All right, so let's go back over here for one more. Let me do a couple more. So let's find the equation of the line. And let's say in this example, where you know that the line is vertical and contains the point -5, 2. Vertical and contains the point -5, 2. Here's your possible answer choices. These are the 4 answers I'll get when I ask that question. X equals 2. X equals -5. Y equals 2. Y equals -5. Okay. And then consider this one as well. Horizontal and a line that's horizontal and contains a point like 3, -4. Okay. All right, and let's do the same thing. So x -4, x3, x3. Y equal to -4, y equal 3. It's one of those 4. Okay, so here's what you should do. Just pause the video and try it, okay? you should plot the point. You don't have to put the tick marks, really. I'm just doing it. Okay. And vertical means up and down. 0.3, -4 would be over here. Let me go ahead and get it plotted. And horizontal would mean it's going to fall like that. You put the X and the Y. All right. So look at that picture. Let's do number 1. Look at that picture. You should have looked at that, and you should have imagined being a point on that line. What can you say always has to be true? And when I'm looking at that line, what I'm noticing is that no matter what, my X coordinate has to be -5. That's my answer. Okay. All right, and then on number 2, I plotted the point 3, -4. The line was horizontal. Now I'm going to look at that horizontal line and I'm going to think about it. If I'm a point and I'm on that line, what's true about every point on the line? Can't say anything about what the X is or what the X is in either direction, but what I do know is I always went down 4. Okay, so that means the equation should be y equals -4. So this one, it's x equals -5, and this equation is y equals -4. And be careful. Watch the directions. If the directions ask for the equation, you want x equals something or y equals something. If they wanted the slope, you would say this one is undefined and number 2 has a slope of 0. Okay. All right, we just got 2 more to do. And the 2 that I have to do here, the last 2 I have to do, deal with lines that have, or problems that have the words parallel and perpendicular in them. All right, so let me go ahead and get a snip of these 2, and we'll work on it. Okay, so I do. Trying to snip it. Here we go. All right, so these 2 kind of go together. They're the same issue. All right, so you have to kind of think about what you're trying to do. You're trying to get an equation, remember, an equation that fits the given information. So I'm looking at that, and I have a point, and then I have this part that says that the line I'm trying to get the equation for has to be perpendicular to this one. This is going to give you your slope. You're going to get your slope from here. Okay. So as you're looking at that, you should be thinking, well, how am I going to get my slope? Well, the line that they gave me, this y equals 1/2 x plus 14, that's in slope-intercept form, isn't it? So I know the slope of that line is 1/2. Okay. All right, but my line is supposed to be perpendicular to that. So remember from an earlier video that when you see the word perpendicular, you should think about the slopes are going to be opposite reciprocals. It's like they're opposite of one another and also reciprocals of one another. So that means you have to, if one's positive, the other one's negative, and that you have to flip it over. So my line would have a slope that's 2/1, and since 1/2 was positive, this one's going to have to be negative, which means the slope is -2. All right, so now what I'm going to do is I'm going to take the point -5, -8 together with the slope being 2, and I'm going to write the equation of the line. So now it's like number 6. We took something real complicated and we made it look like that problem number 6. All right, so after we get all that figured out, we're just going to go in and do the y minus y1 formula. And we're going to keep the y with the y. Slope is -2, and then keep the x with the x. And don't forget, when the points have negatives in them, it's minus a -8 and minus a -5. So that becomes y plus 8 equals -2, x plus 5. Okay. And so at that point, we're going to wind up needing to just clean it up a little bit more. We're going to distribute. So all we're doing from about here to the end is getting it in slope-intercept form. So I'm going to distribute the 2. That would be negative 2x minus 10. And then I'm going to take away the 8 so that the y is by itself. And I wind up with y equals negative 2x minus 18. And that's what they wanted. That's the answer. Y equals negative 2x minus 18. Boom. All right, so when you see the word perpendicular, you should think, okay, my slope has to be the opposite reciprocal or negative reciprocal of the line that they gave me. And so this particular one, the line was already in slope-intercept form, which was helpful because that slope of 1/2, I didn't have to do any work to get that. But that's not the slope of my line. My line is perpendicular to this one. So I had to do the opposite reciprocal of that. All right, now the biggest mistake that's made, I think, is that people can't bear to get rid of that 14. The 14, the y-intercept of that line has nothing to do with your answer. Let me show you. Y equals 1/2 x plus 14 would start at 14 and then it would go up 1 every time you go over 2. Okay, so it might look something like that. This is the 1/2 x plus 14. Okay, the point that you're being given is negative 5, negative 8. Okay, so that was supposed to be 14. So 8 might be like that. Okay, negative 5, 8 might be like that. Let me come in a little bit. Okay, so maybe like right there is the point you were given. Negative 5, negative 8. And your job is to get the equation of the line that passes through this point and is perpendicular. So perpendicular means the line has to go at a right angle to it. So it might look something like that. That's not real good, but I was trying to get it to be at a right angle. And I need the equation for this, and that's what we found when we got y equals negative 2x minus 18. Y equals negative 2x minus 18 is the equation of that line. All right, now when you look at that, do you see the 14 doesn't have anything to do with my new line? This is the 14 right here. My new line, it's got a y-intercept down here at negative 18. I mean, there's no connection. There's no relationship between the y-intercepts. So all you're doing from here is getting the slope. And once you know the slope of your line, once you know that, you're through with all of that information. And you're going to just take your point and that slope and go from there. Okay. All right, let's try one more. All right, now this one, when I read it, I say, okay, I need an equation of a line. The line's got to go through the point negative 3, negative 5, and it's got to be parallel to this line. I'm thinking to myself that I need the slope and that parallel to 6x plus 5y equal negative 63 is how I'm going to get it. Okay. All right, so what I'm going to do is I'm going to take my equation here, and see, I need the slope of this, and I can't tell easily. But if I knew the slope of this, I could then use the fact that the lines are parallel. So whatever the slope of the given line here is, my line is parallel. So it should have the same slope is what I should be thinking. Same slope. So I need the slope of the given line, and then that'll be the slope of my line. All right, so this is the kind of problem where you're just needing to take a problem that's in standard form and get that y by itself. So you're going to subtract the 6x from both sides. That's going to leave you 5y, and then the negative 6x I'll write first. Equals negative 6x plus 63. Oops, minus 63. Almost messed that up. See the minus right there? Okay. And then I'm trying to get the y by itself, so I need to divide by 5. Okay, so I'm dividing that whole side by 5. And then in this context, you want to go and distribute that 5 into both numbers. Okay. All right. So when you look at that, it's now in slope-intercept form, and the coefficient of x is my slope. All that work got me the slope of the given line, and then my line is parallel this time. So it's going to be the same slope as that. So I know my line is going to have a slope of -6/5. So now I'm going to take the point and that slope and write the equation. All right, so I'm through with this. I'm through with all that work. I just needed it to get that slope. And since my line had this, it was parallel, it had the same slope. So now I'm going to go in and do the y minus the y coordinate equals the slope times x minus the x coordinate. Then I'm going to do y plus 5 equals -6/5, and see how that's minus a negative as well. That's x plus 3. Then I'm just working to clean this up, so I'm going to distribute, which would give me a -6/5 x, and you can use your calculator to do -6/5 times 3. Turns out to be -18/5. All right, and then you're working on getting it in slope-intercept form, so you're going to subtract the 5. So that's going to give you y equals -6/5 x, and then I have to do -18/5 minus 5. So that's going to be -43 when you do it. -43/5. I was doing it in my head, but I did this. I rewrote -5 as -25/5, and so -18 and -25 would be -30, -43. All right, and then that's my equation of the line, okay? So when you get to any that say parallel or perpendicular, you have to think about parallel is same slope. Perpendicular, your slopes are opposite reciprocals. All right, let me go to the whiteboard and do one that deals with parallel and perpendicular. What if you were told to write the equation of the line and you wanted it to be perpendicular to x equals 10 and passing through the point -1,5. So write the equation of the line. So that means you want the equation. You want it to be perpendicular to x equal 10, and you want it to pass through the point -1,5. Well, since it involves a special type of equation, I'm going to think about it. I'm going to graph the information. So -1,5 would be like that. There's -1,5. Okay. X equals 10 means all the x's are 10. So make sure you're thinking through that. So all the x's are 10, which means somewhere over here at 10. You don't really need the tick marks, but I'm trying to be precise on my example. Should be a nice straight line. So I didn't do very good. Okay. I would have that. That's x equal 10. Okay. So get these two pieces of information on the graph. Then you want your line to be perpendicular. So you should be thinking that you want your line to be at a right angle to that one. So let me in blue illustrate the line that I'm trying to get the equation for. It's got to be perpendicular and it has to pass through this point right here. So isn't it going to need to be horizontal? Passing through that point, and I'm looking at that and I'm imagining the equation for that. And you know it's going to be a y equals always 5. See, all the y coordinates are 5. You know, if the vertical one is x equal 10, then you know that you're looking for the horizontal one because your line has to be perpendicular. So that would be the equation of the line that's perpendicular, okay, to x equal 10 that would pass through that point, -1,5. Okay, so that sheet right there kind of takes you through a progression of examples where you're being asked to write the equation of the line. So it's kind of backwards from all the graphing that you've been doing. Okay. Now, one more thing. Sometimes they want the equation of the line in standard form. So, you have your slope-intercept, which is the preferred form because of all the information that you get at a glance. Where you got something like that, and you'll know your M and your B. All right. And then the standard form, we don't use it to find the equation of the line ever, but sometimes they'll ask for the problem to be in standard form. So it looks like this. Okay, so here we know the M is the slope, and the B is really 0B, and that's the y-intercept. Well, with this one, you don't get anything at a glance, but I want to say a little more about it. For standard form, what you do is you make sure the x's and the y's are on the same side. The A, the B, and C are nice. They're integers. So that means they come from that set, -3, -2, -1, 0, 1, 2, nice numbers, okay? The set consisting of those, not fractional. So you can always make it so to where they're nice, not fractional. And it's customary to make A positive. Okay. Sometimes it'll be 0. Sometimes you don't have an X term, but make it positive. Okay. All right. So there are problems where after you write the equation of the line, so let's go back to one. So let me take an answer we got. Let me look at the answers. Where am I trying to go? I can't find my SNPs. Still in there? I was trying to get one of our answers from the equation, but I think I shut down my SNPs that I had earlier. Let me see if I can get them back. See if they're still there. Nope. Okay, so let me just go back to the whiteboard and make one up. So here's what I'm getting at. So suppose you did a problem and you got your equation, and this is the equation in slope-intercept form. You went through all the work and you got the equation, and it looked like y equals -3/5 x, and maybe it was plus 7/5, something like that. Well, sometimes they'll say they want it in standard form. So after you get that, you might need to put it in standard form. So this is slope-intercept. So for standard form, that's the one where the x and the y are on the same side, okay? And no fractions. So no fractions, and the x and the y on the same side. So what works really well is to look at the denominators and think about one number that can knock them out. So 5 would work in this case. So what you can do is you can multiply both sides by 5. Okay, so I'm going to do 5 times the y. And then I'm going to do and distribute the 5, because I'm going to do that whole side. See, I'm doing this side by 5 and this side by 5, but I'm going to distribute it. So I'm going to do 5 times the -3/5 x plus the 5 times, oops, I wanted that red, the 5 times the 7/5, okay? And so you see the denominators are gonna, the 5 over 5 would cancel out. That 5's really like 5 over 1. So this would become just -3x. This would become just 7, but then I'd have that 5y over there. So no fractions anymore. That's clearing the fractions. And then to get in standard form, I need to add 3x to both sides so that the x and the y are on the same side. All right. I don't try to put problems on there that involve that, because if it's in slope-intercept form, it's really very nice, because at a glance, you can see the graph almost. You can see the negative slope and the positive y-intercept, and you can think about that. where standard form you can't. But that's the standard form. That's the slope-intercept form that we had. Let me get rid of all that we had to start with. That's slope-intercept. Okay, so there might be a problem where after you get it in slope-intercept form, they ask for it to be in standard. So I wanted to kind of show you how to do that. All right, so let me stop this and get it posted in case you want to spend some time getting ahead over break.